All right, we are about to go on a wild ride through the entire 4.5 billion year story of our planet. I mean, everything, from a blazing ball of fire to the world we see outside our window right now. Let's get into it.
Just take a second. Think about where you are right now. The chair you're sitting in, the ground beneath your feet. It all feels so solid, right? Permanent, even. But for almost all of Earth's history, the very spot you're on was something completely, and I mean completely different. Well, what if I told you that billions of years ago, that exact spot was part of a global ocean of molten rock, boiling away at over 8,000 degrees, and at other times, it was buried under miles of solid ice? You see, the story of our home is one of constant, violent, unbelievable transformation. So let's rewind the clock all the way back to the very beginning. Our first chapter is pure cosmic chaos and fire, back when our whole solar system was just a big empty cloud of dust and gas. It all kicks off with a death, the death of a massive nearby star. It exploded into supernova, sending out this incredible shockwave that rippled through that cloud of dust. That jolt was enough to make the cloud start collapsing in on itself. Gravity took over, pulling more and more material into the center, until the pressure got so intense that a new star ignited, our sun. And all the leftover bits of rock and dust, they started smashing into each other, clumping together, slowly building the planets, including our very, very young Earth.
Now back then, Earth wasn't alone. It kinda had a roommate. A planet about the size of Mars, which scientists have named Theia, was sharing our orbit. But this cosmic dance wasn't gonna last. Eventually, gravity pulled Theia in, and it slammed right into our young planet. The collision was absolutely cataclysmic, blasting a huge cloud of molten rock into orbit around Earth. Over time, gravity pulled that glowing ring of debris together, and it formed our constant companion in the sky, the moon.
Okay, so the cosmic fireworks start to die down a bit, the planet finally begins to cool off. And this is where the story pivots, from just cosmic collisions to chemistry. The stage is being set for maybe the most incredible event in the universe, the beginning of life. So, you have this cooling ball of rock, but where did the water for our oceans come from? Believe it or not, the answer is space. For millions and millions of years, the Earth was slammed by a relentless storm of asteroids. And these weren't just rocks, they were like cosmic delivery trucks, packed with ice crystals, salts, and minerals. They didn't just fill our oceans, they brought the actual chemical building blocks for life itself. You know, life didn't start in some sunny, calm little pond. No way. It started in one of the most extreme places imaginable, the pitch-black, crushing depths of the ocean. Down there, volcanic vents were just spewing this hot chemical soup from the Earth's core. And in that harsh environment, the first microscopic organisms appeared. They didn't use sunlight. They learned to live on pure chemical energy. That was it, the spark.
So for more than 1 billion years, life is just this simple microbial soup, kind of hidden away from the world. But then, one of these tiny little organisms figured out a new trick. And that one trick, it was about to change literally everything.
This new kind of bacteria figured out something revolutionary. It learned to eat sunlight. Photosynthesis, right? It turns sunlight into food. But, like any living thing, it produced waste. And that waste product, that gas it pumped out day after day, was oxygen.
And the change was, well, it was total. Before this, Earth was a completely alien world. We're talking a toxic atmosphere and so much iron everywhere that the oceans and even the sky would have looked reddish, kind of like Mars today. But as oxygen filled the air, it literally rusted the planet. The iron settled out, and for the first time, the oceans and the sky turned blue. But here's the crazy part. For most of the life that already existed, oxygen was pure poison. This great oxygenation event was basically the planet's first ever pollution crisis, leading to a mass extinction caused by life itself. It's a powerful lesson, right? What's a deadly poison for one organism can be the very foundation of life for another. And it didn't stop there. There was another huge consequence. The oxygen reacted with methane gas in the atmosphere, which was a really potent greenhouse gas. It basically broke the planet's thermostat. With way less heat being trapped, temperatures plummeted. The whole planet froze over, turning into a giant snowball hurtling through space for millions of years.
So how do you thaw out a frozen planet? Volcanoes. That's how. They punched right through the ice, pumping the atmosphere full of CO2, warming things back up, and kicking off the next great era in our story. Once the ice melted, things really started to get interesting. All that oxygen in the air formed a protective ozone layer. Think of it as planetary sunscreen. For the very first time, life could actually crawl out of the water onto land. Simple things like moss started carpeting the bare rock. And at the same time, the continents were all drifting together, forming one giant landmass, the supercontinent of Pangaea. Even time itself was changing. The day was getting longer as the moon's gravity slowed Earth's spin.
And yeah, on this huge greening landscape, a new kind of animal showed up. And they didn't just show up, they came to dominate. For the next 150 million years, this world belonged to them. The dinosaurs. The dinosaurs were the undisputed kings. They were masters of the land, the air, the seas. It must have seemed like their reign would never, ever end. But they had no idea what was coming for them from the deep, dark blackness of space. 66 million years ago. Picture this. A chunk of rock and metal bigger than Mount Everest is hurtling towards Earth. And it's not just drifting, it's screaming through space at 80,000 kilometers per hour. And it was on a direct collision course. The moment of impact it's almost impossible to even imagine. Hitting what's now the Gulf of Mexico, it unleashed the energy of 100 million atomic bombs going off all at once. The asteroid itself and miles of the ground beneath it were just instantly vaporized. But the explosion wasn't even the worst part. The real killer was what came next. Trillions of tons of pulverized rock were blasted high into the atmosphere, wrapping the whole planet in a thick, dark blanket. The sun was blocked out for years. The plants died, the animals that ate the plants starved, and then the animals that ate them starved. The whole global food chain just collapsed, wiping out 75% of all life on Earth, including every last one of the dinosaurs. The world went dark and cold for a very long time. But even in total devastation, in the ashes of one world, there's always an opportunity for a new one to begin. The giants were just gone. The survivors, they were the little guys. While the dinosaurs were getting wiped out on the surface, our distant ancestors, these tiny shrew-like mammals, were hiding. They were burrowing underground, just waiting it out. And when the dust finally settled, they crawled out into an empty world, a world without monsters, a world that was theirs for the taking. And this timeline, man, this really puts it all into perspective, doesn't it? Look at that vast stretch of time. Formation, first life, the oxygen, the dinosaurs' long reign, and then way, way over on the far right, see that tiny, tiny little sliver? That's us. If you squeezed Earth's entire 4.5 billion year history into a single 24-hour day, all of recorded human civilization would be the last fraction of a second before midnight. The story of our planet is a story of change, constant, massive, often violent change, from a ball of fire to a snowball to a world of dinosaurs. And now, for the first time in 4.5 billion years, a single species is the main driver of global change. So that leaves us with a really big question, doesn't it? What's our chapter in Earth's long story going to look like?